So today is the trapezoid rule. Trapezoid rule is the method of solving integrals when the antiderivative cannot be found. It's basically how to do an integral by hand. It uses trapezoids instead of rectangles, so it is more accurate in what you're doing than a rectangular method. It is more accurate than that. As a reminder, the area of a trapezoid is 1/2 the height times base 1 plus base 2. If the interval that we're talking about on the integral from a to b, so lower bound a, upper bound b, if the interval is divided into n equal subintervals, so we divide it up into equal parts to do this. It makes it easier. Then h, our height, is the difference from b minus a divided by n. How far apart are they? Okay. So our trapezoids we're working are not what you would consider your typical trapezoid. Yes, they are trapezoids because you have two parallel sides. This is our height. This is our height here. This would be base 1. This would be base 2. That's what we're looking at for our trapezoids. The height is our distance between the two. So we're going to take it from A to B and break it up into equal intervals. Each one of those are exactly the same. That's part of how this works, is they're each exactly the same. So the height for every trapezoid is that distance. It's exactly the same. So the total distance divided up into equal parts. Yeah, that's part of what makes the trapezoid work. Okay. Now, the idea, and you don't need to worry about getting this part down, is I've got some function f, and I'm going from A to B, and I'm dividing it up into equal subintervals, equal parts. I'm dividing it up into trapezoids, each one of them the same distance apart. And I have a trapezoid, which is going to be more accurate than a rectangle. Okay, it's going to be more accurate than a rectangle. Now, in the rectangular method, whether it was an overestimate or underestimate depended upon whether it was an increasing or decreasing function. Overestimates or underestimates depend upon the concavity for the trapezoid rule. It's based on concavity. If it's concave down, it's an underestimate because every line is underneath the trapezoid. If it's concave up, the top of the trapezoid is above your curve. Okay. That may or may not come into play at some point. Now, if we're breaking it up down into subintervals, the distance each interval will have an x-coordinate to go with it. So our first one, our lower bound is x sub 0. Our upper bound is x sub n, n being the number of intervals we break it up into. If it's four subintervals, we have 4 trapezoids. It goes from 0 to 4. Okay, if it's 100, it goes from 0 to 100. If it's 1,000, it goes from 0 to 1,000. Whatever n is how many intervals we break the space up into. So we have x sub 0, x sub 1, x sub 2, etc., etc. Get down to the end. I have x sub n minus 2, x sub n minus 1. Now, when I'm figuring out each and every individual trapezoid, the area of a trapezoid is equal to, we'll start with this first trapezoid here. The area for this first trapezoid is 1/2 our height, which is b minus a over n, the distance from the beginning to the end divided by how many intervals we have, times our two bases. The first base is this length here, the y-coordinate that goes with that x-coordinate, f of x sub 0. And then the other side, our base 2, would be f of x sub 1. That's our first rectangle. Our first trapezoid. Our second trapezoid does the same thing. 1/2 b minus a over n times this base f of x sub 1 plus this base here f of x sub 2 plus, and then we keep going and adding them together. Okay. So how many times are we going to use this height here? Once. How many times are we going to use this height here? Twice. Once in this one, once in the next one. How many are we going to use this one? How many are we going to use this one? And so on. How many are we going to use on this one? Going to use it twice, once for each trapezoid. How many times are we going to use this height here? Just once. That is important. So if we figure out every one of these, we'll have, for each one of these, we'll have something like this. For the last one, when we work this last trapezoid out, it's 1/2 b minus a over n times f of x sub n minus 1 plus f of x sub n. That would be the last one. Okay, and we have as many of those as we break it down into. Okay. If we put them all together, first trapezoid, second trapezoid, third trapezoid, and so on down to the last trapezoid. We're going to add them all together. Well, if we look at it, what do we have the same? In every single one of these, we have the 1/2 times the height. And the 1/2 times the height is exactly the same in every single trapezoid. Once we pull that common factor out, what are we left with? We're left with all the bases. We have the first one once, we have the second one twice, we have the third one twice, we have the fourth one twice, etc., etc. The penultimate one we have twice, and then the last one we have once. And that gives us our trapezoid formula. This formula you need to have down. Okay, by factoring and then combining up like terms, this is the formula for the trapezoid rule. The integral from a to b of f of x dx is b minus a over 2n. That's b minus a, that's 1/2 times b minus a over n, b minus a over 2n, times f of x sub 0, 2 f of x sub 1, 2 f of x sub 2, etc., 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 down to 2 f of x sub n minus 1, 1 f of x sub n, the last one. All your y coordinates happen twice, except for the first one and the last one. This is the trapezoid rule. That is the formula you need to have. Okay, a couple of things about using the trapezoid rule. First, when AP asks you to find the integral using trapezoids, they usually give you a table of values. They don't usually give you a function. They don't expect you to use the trapezoid rule as it stands on its own. They give you a table of values and say use trapezoids to find the integral from here to here, similar to what I did on the quiz the other day. Give you a table of values, instead of asking for rectangles, ask for trapezoids. So you have to understand how to interpret that table of values into a series of trapezoids. Sometimes they are equal length and width, and sometimes they're equal width, sometimes they are not. Kind of depends upon the table of values. You do need to pay attention to that. We'll do some examples when we get closer to that. And I do think one of my homeworks does that. This does work, however, with an equation. Now, usually, like I said, AP, they don't expect you to do this. If they give you one that you cannot find the antiderivative of, then what they do is they let you use your calculator. That's their general rule on the test. If it's an integral where finding the antiderivative is really, really hard or impossible, then that question will be part of a calculator-based portion of the test, and you'll be able to find the integral on your calculator. I've seen that. I've seen ones that are that way. That's usually what they do. Usually. Not to give you enough information to use rectangles or trapezoids and using a table of values or something like that. They don't expect you to do it using the function and this rule. Now, for me, for your test on Friday, you will need to use the trapezoid rule. I often have students that do it directly like this. They fill in the values they need to fill in the form that it stands right now. They plug in B, they plug in A, how many ever subintervals, and I will tell you how many you need to put down to. And then they figure out the first y coordinate, the next y coordinate, and so on and so forth, and they just fill this in, and they add it together, and they give them their answer, which is great. However, I do have a bit of a template, let's say, for how to do this by hand and keeping yourself organized. Okay? So, and I will ask you to find the areas to solve integrals that you can do much easier by hand doing antiderivatives than you can by the trapezoid rule. The point is not to give you something you have to do this way. The point is to give something that you can show me you understand the trapezoid rule and how to do the trapezoid rule without making the numbers so freaking hard you can't do it. Does that make sense? For example, the one we're going to do today is we're going to find the area, we're going to find the integral from 0 to 2 of x squared dx. This is really easy to do using antiderivatives. Can come up with the exact value. I'm giving you an easy one because I want you to work with x squared. I don't want you to work with the square root of x squared minus 5x plus 3 halves, and I can make up some other crap that would be really, really freaking hard to do. I'm not going to do that to you. I'm giving you numbers that are easy to work with. Okay? Because that's not the point. The point is to see, can you do me the method, not can you work these really hard functions. Okay? Now, this table works out really nice to keep your work organized. And the hardest thing about the trapezoid rule is organized work. That's the hardest thing about the trapezoid rule is organized work. And this is what I show is it keeps your work organized. So, first thing you have to do is you have to find your values at the end. Now, n goes to 4. I have 4 subintervals. Let's not start with 1. N starts with 0 because your first interval starts with x sub 0. So I go 0, 1, 2, 3, 4. Those are my nth values. X sub 0, x sub 1, x sub 2, x sub 3, x sub 4. That's what we're going to be working with. What values are those x's? We start with what? We start with our a, our lower bound. Start with 0 and go to 2 and break it into 4 equal parts. So let's see, halfway in between is 1, and then there's 0.5 and 1.5, and decimals are just fine on this. Okay? Decimals are just fine on this. Don't want to do it in fractions because I don't want to work with fourths and all this other crap. So these are the x coordinates that go along our bottom. X sub 0, x sub 1, x sub 2, x sub 3. Now I need to find the y coordinates that match those. So I just plug those into f of x. Okay. So 0 squared, because I put 0 in there. I want to find f of 0. Well, that's my function f. 0 squared would be 0. 0.5 squared, 0.25. Right? Yeah. 1 squared is 1. 1.5 squared is 2.25. Right? And then 2 squared is 4. Now, when we do the formula, we double all of those except for the first and last. So here's what I do. I take the first one, just bring it over. Take the last one, just bring it over. Take the others and double it. So I get 0.5, I get 2, and I get 4.5. Those numbers are these numbers there. That's what's in the parentheses. That's what's in that last column, is that part that's in the parentheses of the formula. Add all those together. That's where the total comes from. So let's see, 4, 4.5, that's 9.5, 10, 11, 12, right? That, like I said, is what this part here is, the part in the parentheses of your formula. Now, that's not my total. That's not what the area is. I still have to get my b minus a over 2n. Well, that's easy. b minus a over 2 times n. 2 minus 0 over 2 times 4, 1/4. I was thinking something's wrong. That's 11, not 12? Thank you. So I'm like doing this in my head, and I'm like, I did it quickly. I'm like, no, that can't be right. I don't think that's. I've done this often enough. I just knew it didn't come out evenly, and yeah. Thank you. That's why I asked. Is that supposed to be 12, or is that different number? You're right, 11. So 11 is not my answer. 1/4 is not my answer. My answer is 1/4 times 11.
And so x sub n is just like
yeah.
splitting up so
yeah, how many spaces do you have? So if I have n is 4, that means I have 4 trapezoids that I'm adding together. My first trapezoid goes from 0 to 1. My second trapezoid goes from 1 to, or sorry, my first trapezoid goes from 0 to 0.5. Second one goes from 0.5 to 1. Third one from 1 to 1.5. My last trapezoid goes from 1.5 to 2. Those are the widths of my trapezoids. These are the heights of each one. So if I kind of look at it this way, this is base 1, this is base 2.
So like if it was like n equals 8, it would be like 0.255.
Yeah, you just break this up into 8 equal parts. Okay, does that make sense? Yeah. And you can take the b minus a and go, oh, that gives me, well, that doesn't give me the whole thing there, but yeah, b minus a over n, not 2n, but over n, that'll tell me what I have. If I did b minus a over n, I'd have 1/2, not 1/4, and I'm going to be moving by 1/2 each time. And so that's my answer. Now, how accurate is that? Well, if we do the integral from 0 to 2 of x squared dx, well, that is x cubed over 3. Evaluated from 0 to 2. So it's 2 cubed over 3 minus 0. So I get 8/3. 11/4 and 8/3. 11/4 is what? It's 2.75. And this is 2.66. Not bad. Not bad, considering I only broke it up into 4. It's not bad. It's not bad. It's pretty close. There is actually a formula to figure out the error. There is a particular formula that you can use to figure out what the error would be, and that lets you define how many subintervals you want to break it up into based upon how accurate you want your answer to be. Depends upon the function, depends upon n, depends upon a couple other things, but there is actually a formula for that. If you want to see something really interesting, you can look it up in your book. There is Simpson's rule, which is more complicated than trapezoid rule. It goes, I believe it's 1, 2, 1, 4, 2, 4, 2, 4, 2, 4, 1, instead of 1, 2, 2, 2, 2, 2, what you're doing for you multiplying it, you have every other one that's multiplied by 4, and I can't remember if it's the second one by 4, the third one by 4. Yeah, it's even more accurate than the trapezoid rule, but nobody ever uses Simpson's rule because it is much more complicated. This will get you what you need. Okay. On your homework tonight, the equations you use, it's just like this. They're not that complicated. You can do it by hand. Use a calculator, come up with decimals. I know there's at least one that gives you a table of values per se you have to use. There might be more than one. Okay? Any questions on this? That's a pretty simple lesson. There's not a lot to it.